All right, for the next topic, it's going to be regarding chapter 6, which is all about naming compounds and determining the different types of compounds, ionic versus molecular. Um, we're also going to look at the different types of chemical bonding. There's 3 different types, and you should be able to differentiate all 3 chemical bonds. All right, the first one here is ionic compound and ionic charge. So ionic compounds are basically compounds containing metals and nonmetals. Okay, so it's a combination of a metal and a nonmetal, or cations and anions. All right, positively charged ions and negatively charged anions. So here's a few examples. We have NaCl, KBr, iron 3 chloride, and silver nitrate. Okay, so you can see that these are all ionic compounds based on their composition, right? So you have a metal, sodium, non-metal chlorine, metal potassium, non-metal bromine, and so on and so forth. So as long as you see a metal combined with a non-metal, automatically that's an ionic compound. Or if you have a cation combined with an anion, that's also an ionic compound. So regarding ionic charge, since we're dealing with ionic compounds here, you should be able to uh, determine the ionic charge for the main group elements. These are the group A elements. The first 4 groups, groups 1, 2, 3, and 4, the ionic charge of these elements basically uh, matches the group number that they're in. So if you have an element in group 1A, the ionic charge is positive 1. Group 2A would be positive 2, 3A positive 3, group 4 positive 4. But once you get into the non-metals, so these elements in groups 5, 6, 7, and 8, these are all non-metals, mostly non-metals. And so non-metals tend to gain electrons. And so they would gain a negative charge. Starting with group 5, like nitrogen, um, essentially you subtract the group number minus 8. So that would be 5 minus 8. 5 minus 8 equals negative 3. And so group 5 would have a negative 3 ionic charge. And then 6 minus 8 is negative 2. 7 minus 8 is negative 1. And then 0. So negative 3, negative 2, negative 1, and 0. So here's a few examples. You have sodium ion. It has positive 1 charge. Magnesium ion with positive 2. Aluminum 3 plus. Silicon 4 plus. And then starting with nitrogen, which is a nonmetal, you have a nitride ion, oxide ion, chloride, and then argon. A lot of noble gases, or all noble gases, will have a neutral charge. Another concept that we covered in chapter 6 is regarding Lewis dot symbols. So Lewis dot symbols essentially contain the symbol of the element surrounded by dots, and these dots represent the number of valence electrons. So let's take a look at a few examples here. We have sodium, magnesium, aluminum, silicon, all the way to argon. And these are all elements on the 3rd row in the periodic table. So sodium, being in group 1, would have 1 valence electron. And so you would put a single dot around it. So this is the Lewis dot symbol for the sodium atom. For magnesium, magnesium is in group 2, and so it has 2 valence electrons. You would put 2 red dots or 2 dots surrounding magnesium. And then aluminum would have 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7, and argon 8 valence electrons. So on the test, this should be a freebie, right? You should be able to identify or select the correct Lewis dot symbol for any elements in the periodic table. All right. You also learned about naming ionic compounds, and you learned that there are two different types of ionic compounds. There's type 1 ionic and type 2 ionic compounds. So the type 1 ionic compounds, I also included the silver, zinc, and scandium because of the fact that you can easily predict the charge on these ions. So silver will always have +1, zinc +2, and scandium +3. Ionic compounds, or type 1 ionic compounds, are those compounds containing group A metals. So group A metals are the main group elements. So you have um, sodium group 1A, group 2A, group 3A. So those are type 1 ionic compounds. So here are some examples. So you have calcium, which is in group 2. It's a group 2 metal. Magnesium group 2A as well. Aluminum group 3, potassium group 1. Right? So that's how you identify what kind of ionic compound you have. The reason why we have two different types is because we named them differently. So let's take a look at type 1 first. This one is calcium chloride. Right? So you have calcium here, chloride, calcium chloride. Here we have magnesium nitride. So remember that these nonmetals, they all end in IDE. So you have a chloride, nitride, sulfide, phosphide. Magnesium nitride, aluminum sulfide, potassium phosphide. All right, and whenever you're determining the chemical formula from a given chemical name, you can use the crisscross method. So here's a few examples. We have strontium oxide, lithium nitrate, and aluminum sulfate. So the first thing that you want to do here is determine the symbol of the element and its charge, and then perform the crisscross. So strontium, you look at the periodic table, that's Sr, and it's in group 2, so it has a +2 charge. An oxide ion is oxygen with a -2 charge. And then you perform the crisscross, and you would get Sr2O2. But because this is an ionic compound, you would simplify that into SRO, strontium oxide. All right, we can do the same thing for the second one here. We have lithium nitrate. So you look at the periodic table and then identify what the charge of the lithium is. It's +1, so that would be Li plus. And then the nitrate is a polyatomic ion with a -1 charge. So that's NO3 with a negative. Perform the crisscross, and what you get is LiNO3, lithium nitrate. And for the last one, we have aluminum sulfate. Aluminum is in group 3, so it has a +3 charge. And a sulfate ion has a -2 charge, SO4 with a -2. All right, perform the crisscross, and what we get is Al2, and then the sulfate ion in parentheses, and then 3 outside. Al2, SO4 in parentheses, and 3 outside. So aluminum sulfate. All right, and now we're going to get into the type 2 ionic compounds. So type 2 ionic compounds contain transition metals. Those are the elements in the middle of the periodic table. And we're also including lead, Pb, and tin, Sn. So lead can have a +4 charge or a +2. Same thing with tin, you can have Sn4 plus or Sn2 plus. Okay, so these are the compounds or ionic compounds containing group B metals or the transition elements. Here are a few examples. We have FeCl3, Ti2O, and so on and so forth. How would we name these ionic compounds? So the first thing that you want to do here whenever you're naming them is to reverse the crisscross, okay? Because we want to know what the charge is on the type 2 metal because they can have multiple different um, ionic charge. You can, for iron, for example, you can have a +2, +3. Titanium, you can have +2, +4. Cobalt, +1 or 2 positive, and so on. And so if you reverse the crisscross, you can get the charge on that metal. So the 3 goes up here, so you have Fe3 plus, and then chloride -1. Remember that the anions or the nonmetals will always have a negative charge. So here now you know that the charge of the iron is +3. So you would name this iron 3 chloride, right? You have to specify what the charge is using Roman numeral. All right, and for the second one here, we have Ti2O. Again, you're going to reverse the crisscross here, and you can see that titanium would have a +1, and then the oxide -2. And so you would name this titanium 1 oxide. Titanium 1 oxide. And for the third one here, we're going to reverse the crisscross as well. So 2 goes on the cobalt, 3 goes on the nitrogen. And so we have cobalt 2 nitride. Cobalt 2 nitride. And for the fourth one, we have copper and an oxygen here. So when you reverse the crisscross, you have copper plus and oxygen with a negative sign. Now, when you look at this nonmetal oxide ion, it doesn't have the correct ionic charge. And so you would have to correct this and multiply it by 2. And when you multiply this by 2, you would do the same thing for the cation here. So multiply both by 2 and you get the proper ionic charges for the copper and the oxygen. So we would name this copper 2 oxide. All right. What if you're given the chemical formula and you have to come up with, or I'm sorry, what if you were given the chemical name and you would have to come up with the chemical formula? How would you do that? Well, we can use the crisscross method here. So we have two examples. We have iron 3 oxide here and tin 2 chloride. You can see that the iron 3 here, iron 3 oxide, the iron has a +3 charge. The oxide has a -2 charge. And so when you crisscross, what you get is Fe2O3. All right, and for the tin 2 chloride, tin SN would have a +2 charge, and then the chloride has a -1. Perform the crisscross, and what you get is SnCl2, tin 2 chloride. So that's how you name type 2 ionic compounds. So that's how you name type 2 ionic compounds and how to determine their chemical formulas. All right, and for concept number 19, make sure that you're familiar with these polyatomic ions, that you're able to recognize these polyatomic ions. All right, so I've listed, let's see, 2, 4, 6, 8 different ones here, the chemical formulas, and also their names. So the first one, we have a nitrate, bromate, carbonate, and then we have iodate, chlorate, sulfate, phosphate, and ammonium. And from here, you can generate a lot more other polyatomic ions that contain one less oxygen or one extra oxygen. So for example, the first one here, we have NO2 with a negative charge, so it has one less oxygen, and the name changes from nitrate to a nitrite. So we're essentially replacing the suffix ate with ite. All right. So we have nitrite, bromite, bicarbonate. So that's kind of an exception here. Instead of subtracting one oxygen, we're adding a hydrogen to the chemical formula, and then deducting one from the -2, so we have a -1. So this is called a bicarbonate ion. And then we have iodide, chloride, sulfite, and phosphite. You can generate more polyatomic ions that contain one less oxygen from the uh, chloride, for example. This would be a hypochlorite. So you're essentially just adding the prefix hypo in the chloride. So that indicates one less oxygen. Or you can have one extra oxygen from the chlorate, and you would add the prefix per. So what we have here is a perchlorate. Right, so that's ClO4 with a negative charge. All right, we're almost done here. If you give me another 10 to 15 minutes, we can finish the review. All right, so how do we name molecular compounds? So the polyatomic ions that we just looked at, um, you can apply what you learned about type 1 and type 2 in naming ionic compounds containing these polyatomic ions. So naming molecular compounds is personally a lot easier compared to naming ionic compounds, just because all you have to do is use prefixes. Okay, so molecular compounds are compounds containing nonmetals only, and they are also known as covalent compounds. So let's take a look at these prefixes here. So you have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So these prefixes basically indicate how many atoms you have of that element. So if you have mono, that's single atom, di means two, tri, three, all the way to deca, which contains 10 atoms. I mean, of course, you can go further than uh, 10, but we'll stop at deca. So whenever you're naming these molecular compounds, you would have a first prefix followed by the first element, the name of the first element. But you don't have to include mono for the first element. You can just skip that. And then you have a second prefix for the second element. And the second element has to end in IDE. So like, for example, if you have an oxygen as a second element, you would call that an oxide. Okay. If you have chlorine as a second element, that would be a chloride. If you have uh, a sulfur as a second element, that would be the sulfide. So let's take a look at these 5 examples here. These are all molecular compounds, right? So when you analyze the chemical formulas here, you can see that they're all nonmetals, right? Sulfur and oxygen are both nonmetals, and so you can name these molecular compounds accordingly. So the first one here, we have one single carbon, so you wouldn't call this monocarbon because it's the first element, right? You skip mono. And then we have 4 atoms of bromine, so that would be a tetra. So we have carbon, tetrabromide. It ends in IDE. Carbon, tetrabromide. The next one here, we have sulfur and an oxide, and we have 3 oxygen atoms, so that would be a tri. So that's sulfur trioxide. The third one here, we have NO. We have single nitrogen and a single oxygen. So that would be nitrogen monoxide or nitrogen monoxide. And the fourth one here, we have PCl3, one phosphorus and three chlorine atoms. So that would be phosphorus trichloride. And then the last one, we have XeF2, that would be xenon difluoride. So as you can see, naming molecular compounds is a lot easier compared to naming type 2 ionic compounds, or type 1 and type 2 ionic. All right, this one is the second to the last one. We have chemical bonds, bonding electrons, and non-bonding electrons. So you learned in chapter 6 that there are three different types of chemical bonds. There's ionic bond, covalent bond, and metallic bond. Ionic bond is the chemical bond in ionic compounds, and it involves the transfer of electrons from the metal to the nonmetals. So remember that metals tend to lose electrons and the nonmetals tend to gain electrons. Covalent bonding involves the sharing of electrons. So electrons are being shared by nonmetal atoms that are involved in that bond. And finally, metallic bonding, the metal atoms are submerged in a what they call sea of electrons. And this is the bond utilized in metals. So looking at a covalent compound here, a molecular compound, we have ammonia, and ammonia contains bonding electrons and non-bonding electrons. Okay, so the bonding electrons, or the non-bonding first, I guess, these are the electrons that are not involved in bonding, and that's why they're called non-bonding electrons. And they're also known as lone pair. Okay, so this one right up top that's on the nitrogen atom is called a lone pair, containing two non-bonding electrons. And then the rest here are bonding electrons or bonding pairs. So this bond between nitrogen and hydrogen is a bonding pair, and same thing here for the rest of the bonds. All right, so for this compound ammonia, you have a total of 6 bonding electrons, right? You have 2, 4, and 6. So that's a total of 6 bonding electrons or 3 bonding pairs. All right, and 1 lone pair here, or 2 non-bonding electrons. So this is a slide here. We have single, double, triple bonds. You should be able to differentiate all 3 different bonds here. So here's a molecule containing single, double, and triple bonds. So these are called single bonds right here. So you have 1, 2, 3, 4, and 5 different single bonds. And a single bond contains a pair of bonding electrons. Okay, one bonding pair. And you can kind of guess what double and triple bonds are. A double bond contains 2 bonding pairs, and then a triple bond contains 3 bonding pairs. All right, so I believe that's the end of this review.